Let's learn about Maya's geometry constraint. The geometry constraint connects an object's position to a surface, whether it be a NURB surface, a NURBS curve, or a polygonal mesh. Let's go ahead and learn how to use this constraint. It's actually a really neat tool. Head over to our animation module, and I'll go ahead and create a cube. This is just for testing purposes. Alright, so we have our mesh. I'm going to just move this over. Let's go ahead and now create an object to connect to the cube. We can use a locator for that. So to apply the constraint, we grab our surface first, followed by our object to constrain to the mesh. Now we can choose the geometry constraint. Taking a look at our options, we only really have just one option that gives us control over the constraint's weight. So this goes from a value of 0 to 10. We'll go ahead and now choose add. And taking a look at the geometry constraint, if we take a look at the node that's been tied to the constrained object, our locator, you can see again we just have a few parameters here to tweak. Here's our weight value set to 10. The value, if it was set to 1, it would still give us full control, meaning that this object would be glued down to the surface. However, going back to the locator, if we were to set that weight to 0, grabbing the surface, no longer is the locator tied to this boundary. So let's go back to our locator. We'll go to the weight. Again, set that back to 1. So again, look at this behavior. You can see that the locator is moving along the surface. You can use this for some really neat rigs, which we're about to take a look at. But this is what the geometry constraint does. Again, it locks an object's position to a surface. It's position only. So taking a look at this, if we were to grab our locator, head over to display, transform display, local rotation axes, we can grab our cube and start to rotate that, and you can see the orientation of the locator stays the same. It does not change at all. Alright, so how can we use this practically? Well, let's say we go ahead and take these objects. We can either store them in a layer or just remove them. I'm just going to go ahead and delete them, being that they're not needed. If we were to go ahead and template our character's layer, what we'll see is a polygonal plane. And this has been parented to our character's arm. I'll go to show joints. So with the plane selected, I'll hit the up arrow. Notice again it's parented to our arm bone. So what we're going to do is use this as a boundary, and we're going to create a gauge. What the gauge will control is the triggering of a blend shape for this character's bicep and also for elbow definition. So if we were to bring the mesh back and hide our joints, when we select our arm that has the blend shape node tied to it, let's go ahead and grab that B shapes our arm, go to the blend shape weight and start to move that, you can see that we have this little bicep bulge. Alright, so what we're going to do is connect a locator to the surface, and then as that locator starts to move up and down based off of the movement of our arm control, we'll then have that trigger our bicep. So this is a really neat use for a geometry constraint. Let's say we get right to work. I'll go ahead and template our character, and we'll go ahead and create another locator. Just to stay organized, let's go ahead and give this locator a name. We'll call it LOC underscore GCNS for geometry constraint, so we know what it's used for, underscore R arm flex 01. So this is to trigger our arm flex. Let's now geometry constrain it to our surface and take a look at another really neat feature about working with geometry constraints. So again, we grab our surface. Following that, we'll grab our locator and apply the geometry constraint. Okay, it might be a good idea also to bring down the size of our locator, let's say to about a value of 0.1 in its local scale. So take a look at this. Even though this locator is locked down to this surface, as we start to move this around, you can see we are still freely able to animate on top of this without having to interfere with the constraint's weight. You can see that we freely can, again, animate on our transform channels. So where this becomes useful is when we want this object to move precisely with another object we'd want to have it constrained to. So let's take a look at this. If we were to grab our plane and start to move this around and undo, you could see that we don't quite know where the locator will end up. So that's a downside. However, we can fix this by constraining the locator to another object. And as we do that, the locator will still be constrained and confined to this boundary, this polygonal plane, which is really neat stuff. So what we're going to do is we're going to point constrain with a maintain offset this locator to our arm control. That way, as the arm control moves up and down, that will be our gauge. So then we'll be able to set driven key between our locator and the blend shape, so that as the locator moves, when the arm moves up, that will thus trigger our blend shape to create the bicep bulge. All right, so let's say we bring back our joints. We'll go to display, animation, joint size, if we need to, just to bring down the size of the joints so they're a little bit easier to work with. All right, now let's go ahead and grab elbow A, this first elbow joint, this double elbow rig. And then we'll grab the locator tied to our polygonal plane, and we'll create a point constraint. So we'll just go to constraints, and we could use a maintain offset, but it might be safest to actually have this tied to the arm control. But what we're doing is just making sure that the locator will be aligned to the bottom of our plane. So once this is done, we can go ahead and remove the point constraint. I'll go ahead and choose apply, making sure that we have our settings set to default. So let me just go ahead and choose apply again, resetting our settings. Let's go ahead and try that again. Might want to remove the point constraint. Just go to the outliner. There's the locator, and I'll go ahead and go in and delete the point constraint. Okay. So at this point, again, we grab elbow A, we grab our locator, and choose apply, and now the locator is going to pop to the space it needs to. All right, so once it's there, once we found the spot where it should start at, what I'll now do is go in and remove the point constraint. Again, we'll just go ahead and get rid of it. We'll take the locator. We'll want it to be parented to our arm the same way the polygonal plane is. So we'll just go ahead and shift select our arm bone and press the P key. All right, now at this point, we'll go ahead and freeze transforms on our locator just to kind of clean it up so it's easier to create a set-driven key. So we'll just go ahead and choose freeze transforms. Okay, great. All right, so now, again, using the point constraint, this time we would like to point constrain the locator to our arm control. All right, so this time we can go ahead and work with maintain offset. Grabbing our arm control, we'll go in and grab the locator. If you need to, feel free to do that from the outliner, but it should be not a problem to grab it from our viewport. So at this point, we could go ahead and choose add. Okay, great. So notice we still have 0 values for our locator, but the point constraint has been created. So that's great. So watch this. If we were to go ahead and grab our arm control, and I'll hide joints, as we start to move this up, you can see that now our gauge is created. As we start to move the arm up, You can see the locator is also moving up. As we move it down, the locator moves back down. If we go ahead and undo, the locator is going to be positioned at the same spot it was point constrained in. All right, so no longer is the locator moving all across the surface. All right, so let's say we go ahead and finish up our work. We now need to decide what axis to tie the set-driven key into to drive the blend shape. So in our case, it's going to be the x-axis. To know this for sure, we could always select that from the channel box. Or if you were to hold down the W key and hold down the left mouse button, you'll find your Move Tool options. Then we can choose the object mode. And then again, that will clearly show us that it's the x-axis we would like to use for our set-driven key. So let's go ahead and finish up. We'll go to our Animate menu, Set-Driven Key, Set Options. We're going to go ahead and load the locator as the driver and choose the x-axis. The driven will be our blend shape node. So let's go ahead and untemplate our character, grab our character's arm, select the blend shape node, and now go ahead and choose Load Driven. You'll notice that the node is now loaded in. Okay, great. So at this point, I'll go ahead and now grab the actual parameter that we need to tie down with a set-driven key. And we're going to go ahead and choose Key Selected just to make sure that we lock down this default position. Now, let's go ahead and take the arm and move that up to the point where the bicep should bulge and where the locator moves to the top of the plane. And now we can go to our blend shape node. Let's go ahead and select it. Get this little error here. It's saying that the attribute name is not read, but it's just a little warning we get sometimes when dealing with blend shapes. Nothing to be concerned about. But now selecting the blend shape, might even need to grab the character's arm to do that. If we were to go back to our blend shape node and set this to a value of 1, you can see that now the bulge has been activated. So watch this. Now, when we grab our weight again and choose key, you'll see that as we start to take our arm and start to move that around, there's the bulge we get in our bicep, which is really neat. So this is just a trigger for a muscle that we've just created with the help of Maya's geometry constraint. So that's a look at the geometry constraint. Again, it is used to tie an object to a surface or to a mesh. We could even use it to constrain an object to a curve, but we still have full control over the transform channels of that object, which is really neat stuff.